Hello everyone. In today's lecture, we will discuss about characteristics of an EOQ system. Let's start with the example problem. A store sells a product that has a constant daily demand of 5 units per day. The store places a replenishment order of 50 units to its supplier every 10 days. The unit purchase cost is $130 per unit. The supplier sends each order in one shipment. The order lead time is 4 days. It costs the store $75 to process, receive, and unpack a shipment. The cost of keeping the product in inventory is $15 per unit per year. The store sells the product for $240 per unit, and it operates 250 days a year. We will calculate several characteristics, including average inventory level, the length of the inventory cycle, the time between orders, number of orders, and more. The few important information that are needed in the calculation are daily demand, order quantity, days per year, and order lead time. The following graph showing the movement of ending inventory level in our EOQ system. We assume that the inventory start at the highest level at 50 units because the order quantity is 50 units. And the store will sell 5 units per day. So at the end of day 1, the ending inventory will be 45 units. At the end of day 2, it will be 40 units. On and on, as you can see that the whole 50 units will be depleted at the end of day 10. That's complete one cycle of inventory. That's why you can see the length of the inventory cycle is 10 days. And then, following EOQ idea, a new shipment must arrive. So in this case, it's 50 units. Another 50 units will arrive just before the inventory is totally depleted in order to avoid stock out. Then a new inventory cycle will start. 50 coming down to 45, 40, and so on. Another 10 days, it will be depleted again, and a new cycle of inventory will start again and again. So this shows that the length of the inventory cycle can be calculated as 50, which is Q, divided by daily demand of 5. So Q divided by D is 10 days. Next, we can see that the highest inventory is 50, the lowest is 0, and the rate of consumption is same. Then the average inventory level will be simply 50 plus 0, which is 50, divided by 2, equals 25. So the average inventory level is 25 units. Now we will see another similar, actually the same graph, but we are going to discuss about reorder point, lead time, and time between orders. So we recall that the lead time, the order lead time is 4 days. In order to receive a new shipment at the end of day 10 or at the beginning of day 11, we need to place an order 4 days earlier. So 1 day, 2 day, 3 day, 4 day. So at the end of day 6, a new order must be placed. Or we can say when the ending inventory hits 20 units, a new order must be placed. That 20 units is called reorder point. 4 days times 5 units per day. That's the total demand during lead time, which is 20. So the order is placed there. It will arrive, say, at the beginning of day 11, and the new cycle will start again. Coming down until it hits 20, another order must be placed. On and on. One order in each cycle. As you can see, the time between orders will be 10 days. It's 10 days because the length of the inventory cycle is also 10 days. So there is no specific formula for time between orders, but if we know the length of the inventory cycle, then we know the value of time between orders. And finally, we can do some calculation here. So we have seen that the average inventory level is simply Q divided by 2, which is 25 units. And then the length of the inventory cycle can be calculated as Q divided by daily demand, which is equal to 10 days. Now, there are 250 days in 1 year, and each inventory cycle has a length of 10 days. Consequently, there will be 25 inventory cycles a year. 250 divided by 10. The store places an order in each cycle. Consequently, there are 25 orders per year because there are 25 cycles of inventory in a year. Then the formula will be days a year divided by length of the inventory cycle, which is equal to 25. Means 25 orders per year. On the other hand, we can think that the yearly demand is 1,250 units and the order quantity is 50. In order to have those 1,250 units, the store must place 25 orders per year because 50 times 25 is 1,250, or the yearly demand divided by order quantity is 25. It means 25 orders per year. So we have two different ways to calculate number of orders per year. Finally, the reorder point can be calculated as daily demand times the order lead time. So in this case, 5 units per day times 4 days equal 20 units. This concludes the lecture. Thank you.